show that the period of e to the z are the integral multiples of 2 pi I. That is, if e to the z plus lambda is equals to e to the z for all z, then lambda is an integer times 2 pi. Sorry, this is a typo. It's supposed to be integer. Okay. So we have, let me write this equation. E to the z plus lambda is equals to e to the z. Okay. Well, the exponential function is never 0. Since the exponential function is never 0, we can divide by it. So we can divide two sides by e to the z. When we divide both left hand and right hand by e to the z, we have e to the lambda equals to 1. Okay. Well, lambda, we can let lambda equals to x plus iy. Okay. We can substitute the lambda, which is x plus iy, equals to 1. And we know that from Euler's formula, e to the iy is the same thing as sine, oh, I should write cosine first. Cosine of y plus I sine of y. Okay. So we can rewrite this equation as e to the x from the exponential rules. We can write e to the x plus iy like this. E to the x times e to the iy equals to, oops, sorry, e to the x, e to the iy as times cosine of y plus I sine of y equals to 1. Okay. We can distribute e to the x. We have e to the x cosine y plus I sine, oops, plus e to the x I sine y equals to 1. Well, this part is equals to this part, and this part is equals to this part, which is just 0. And so we can have e to the x cosine y equals to 1, and also e to the x times I sine y equals to 0. Okay. Here x must be 0. Then cosine of y equals to 1. For cosine of y equals to 1, y must be some integer n times pi. Okay. And don't forget, in order it to be a positive 1, n must be even. So here n must be 2 times k, where k is an integer. Okay. Oh, I should have write that like this. K is an integer. And for e to the x times I sine y equals to 0, x, yeah, the same thing, 0. For I sine y, for the value of y to make sine y equals to 0, y must be n pi. Okay, since we already have n equals to, oops, this must be two k. Since we have n equals to 2k, that means y 2k pi. Okay, well, if we look at this equation again, e to the x times cosine y plus e to the x I sine y equals to 0. We know that x equals to 0 and y equals to 2k pi n. Oops, just 2k pi, okay? Where k is an integer. Okay, let us input the values. So e to the 0 times cosine of 2k pi plus e to the 0 times I sine of y. Okay, so let us test if k equals to 0. This one 1, and cosine of 0 plus 1 times I sine of 0. Well, it equals to, well, this should be 1, sorry, not 0. 1. 1 times cosine 0 is just 1 plus 1 times I sine 0. Sine 0 is just 0. That means e to the x times e to the iy is equals to 1. We have x equals to 0 and y equals to e to the I times 2k pi equals to 1. So e to the 2k I pi is equals to 1. That means lambda is equal to 2k I pi. That means, so we have e to the z plus lambda is equals to e to the z. So e to the z plus 2k I pi is equals to e to the z. So this proves